All right, today we're going to review a topic back from Unit 3, but now that we've studied Unit 5, we think it'll make more sense to you. So today we're going to talk about if functions are even, odd, or sometimes even neither. We're going to be able to use three ways to determine this. We can use a graph, we can use algebra, and we can use the function itself. I think the best way is to look to see at the graph first. So our definition is a function is even if it is symmetric about the y-axis. So that means that if you fold it across the y-axis, it should match up. We're familiar with the idea of symmetry or reflection back from Unit 5. So here's an example of something that is symmetric across the y-axis. You can see that if you fold it along the y-axis, point A and B will match up. This is the function f of x equals x squared. When you plug in 2 and negative 2 into each of the functions, you notice the result is 4. We can conclude then that when you have f of x equal to a number and f of negative x equal to the same number, then the function is going to be even. All right, let's take a look if it's odd. A function is odd if it is symmetric about the y-axis and the x-axis. Another way to think about this is if you rotate it 100 degrees or 180 degrees around the origin, see if it matches up. So let's take a look at this graph right here. If I do a quick little trace and I try to rotate this, let me slide it a little bit, 180 degrees around the origin, if you notice, you get something that looks virtually the same. So that's what it means to be an odd function, if you rotate this. Now, let's look at f of x equals x cubed. Notice this time, if you plug in 2 and negative 2, you're going to get the exact opposite. Here, you're going to get 8, and here you're going to get negative 8, as you can see on the graph. So now we can conclude that f of x equals n, and if f of negative x is equal to negative n, then the function is going to be odd. So here you notice the input and its opposite input give you the opposite output this time. All right, lastly, it's neither if it's not symmetric about the y-axis or the origin. So here we've got an example of a line. The equation of this line is f of x equals negative x plus 3. As you can see, when you plug in negative 1 into the function, you get 4 as its output, and when you plug in 1, you get 2. So these are neither the same nor the opposite, so we would call this function neither. So again, let's look at those pictures real quick again. This one's even because if you fold it across the y-axis, it's the same. And notice when you put in negative 2 and 2, you get the same output. This function was odd because when you rotated 180 degrees around the origin, you got the same figure. Again, if we look at the input of 2 and negative 2, we get the opposite outputs. That makes it odd. All right, so let's look real quick. What do you think about this graph? This graph is going to be odd. If I take this line and I rotate it 180 degrees around the origin, we get virtually the same figure. So that's going to be odd. All right, what about this one? Looks very similar to our example, but consider if you draw a vertical line down the y-axis, does it look like it's going to match up? Yes, in fact it does. So that one's going to be even. And what about this one? Because it's not centered at the origin and it's a line, it kind of gives it away that it's going to be neither. You can play around with that as you can to see if you fold it across the y-axis or rotate it 180 degrees if it would match up. All right, let's take a look at a few more examples. We're going to plug in the values 3 and negative 3. Now remember, if the output is the same, then it's going to be even. If the output is the opposite, then it's going to be odd, and if it's neither, then the function is going to be neither. So let's look at x squared plus 1. I went ahead and put in our 3 and our negative 3 into our function, so 3 squared plus 1 gives us 10. Now, if it's going to be even, we're also going to get 10. If it's going to be odd, we're going to get negative 10. Let's see what we get. Negative 3 squared is 9. 9 plus 1 is 10. So indeed, they are the same, so we can say that our function is going to be even without looking at the graph. All right, what about x cubed plus 3? So 3 cubed plus 3 is going to be 27 plus 3, which is going to give us 30. Let's see what we get when we plug in negative 3. Alright, so this time when I get negative 3 cubed, that's going to be negative 27 plus negative 3. That gives me negative 30. So remember, we got 30 when we put 3 in. We got negative 30 when we put negative 3 in. So since we got opposite results, we're going to let you know that it's going to be an odd function. Alright, last example. Again, I've already set it up for us. We're going to use x cubed plus x squared. So 3 cubed gives us 27 plus 9 is going to be 36. What happens when we put in negative 3? So here we get negative 27 plus positive 9. That's going to be something but not equal to 36. So we know that our function is going to be neither. So can we make a conclusion from what we see here? If all of the exponents in the function are even, the function's going to be even. If all of the exponents in the function are odd, the function's going to be odd. And if there's a combination of even and odd, the function's going to be neither. As you can see right here, we have an odd exponent and an even exponent, so I knew before I even plugged in my values that it was going to be neither. What's the exponent here? Well, that exponent is going to be the exponent of 1. 1 and 3 are both odd. And what about here? Could I rewrite this as 1x to the 0 power? Yes, because x to the 0 is 1. 1 times 1 is 1, so I haven't changed the value of that. So let's look at these examples. We've got a power of 3, 2, 1, and 0, so that's going to be mixed. That's going to be neither. Here we've got a power of 2, and remember, this is a power of 0, so that one's going to be even, since both of those exponents were even. And here we have an exponent of 3 and 1, so that's going to be odd. So we can look at both functions, graphs, and equations to tell whether functions are even, odd, or neither. Take a few minutes to try the examples on your own and make sure you understand these definitions. If needed, go ahead and re-watch the parts that you need to. All right, good luck.